Hi everyone, we are Team Woof, working with the Wegmans Organic Orchard and Farm.
I'm Derek Young.
So first off, we'd like to say a big thank you to our faculty coach, Professor Ken Martinez, as well as the entire team from Wegmans that's been working with us this semester. Nate, Pete, Tony, Mike, Brandon, and Chris, you guys have been really great to work with, and we really appreciate the time that you've put into working with us. So first off, I'm going to go out on a limb and say that everyone in the room is familiar with Wegmans supermarkets. Yeah? What you may not know is that Wegmans also has an organic farming facility just out in Canandaigua that is a fully functioning organic farm. They generate produce that gets distributed to local area Wegmans as well as a few other customers. But they're not just an organic farm that's spinning up organic produce. They are also a research and development facility. So this dual role that it holds creates a unique problem where they're not just tracking soil cultivation and pesticide use to make sure that they can remain certified an organic farm. They're also tracking all the ins and outs of everything that happens to a crop during its entire life cycle on that farm. They want to learn from it, they want to compare it to past data, to future data, to create those best practices that they can then go share with their partner growers.
So as you could imagine, that's a lot of data to keep track of. So right here is the current process for what they're doing to track the data. On the left, you'll see a laminated note card. These are brought into the field by all the workers, and all of that is shorthand notation for things such as what task was done, what exactly was done on it, and the hours and who's done it. This data is then taken and transcribed into the spreadsheet on the right by a single user. So this is where the process kind of bottlenecks around one person being available to put all of this in. Right now, what Wegmans wanted was something a little more complicated than a spreadsheet to store all this data, and we are the first attempt at a software solution that is more fitting for this. So luckily enough, Wegmans came in with a pretty good idea of what they wanted from the product, and they described these main key features of the product. First of which being traceability. So a lot of the data is a lot easier to be stored in a web solution, and a lot of the data needs to be kept a detailed audit trail so that they can maintain their organic status. After this, yield estimates are also important. So going in and planting something, they want to know what they can hope to get out of the crop once it's put in, and right now it's based mostly off of Excel formulas and a lot of user expertise, but we're hoping to migrate this more into historical data so that they can make better informed decisions. Task reporting is also a huge part of this. So not only does this system going to track the hours, but also set up some sort of accountability for who was responsible for what in case something goes wrong. And probably most importantly is usability. So these aren't necessarily going to be technical users, so it's important that we can get a system up and going where they don't need a lot of expertise to jump in. Some things that on this semester we focused more on getting the data in, and next semester our focus is going to be more on usabilities, but we do have plans for things such as in-app documentation so that the user doesn't necessarily need to go out and ask someone if they have a question. They can answer it right from within the application.
So a little bit about our process. In choosing our methodology, we considered a number of different factors. Probably the biggest red flag in pointing us away from Scrum was that our requirements were pretty well established really early on. But what made this a unique problem is that none of us have really dealt with agriculture before. I was the expert in the group for having a garden when I was a kid. So we're completely in uncharted waters, and our perceptions of these requirements and what they really meant to the sponsor and to the user was going to be changing over time. And that we felt we would get a lot more out of iterative feedback and iterative releases to the sponsor. So that was one of the key reasons. We also had a readily available sponsor team that was really excited and really willing to work with us, and we didn't want to pass that up. We really wanted to take the best advantage of that we could. In implementing Scrum, we decided on 4-week sprints, and each week we were able to meet every single weekday in person, the 4 of us as a team, including the meetings with our sponsor and our faculty coach. We also decided to use Microsoft Team Services as our main project management tool. There was some discussion of Jira versus Team Services, but in the end, Team Services created this all-encompassing product that was able to manage our code repositories, our process with backlogs, acceptance criteria, story points, as well as builds and releases. One of the pain points that we encountered was that the charting and graph creation wasn't as powerful as we expected and wasn't quite to the specifications of what we wanted to track. So although the data is being scraped directly from Team Services, the actual charts themselves were made in separate spreadsheets. A little bit about domain analysis. Like we said, none of us were experts in agriculture. We were really novices. And it was really helpful coming in that the Wegmans team had a clear-cut description of what was a must-have and what was a nice-to-have. It created an easy set goal for us to have the must-haves completed by the end of the first semester, and that the nice-to-haves would be pushed off to the spring. Iterating on elicitation was a big thing for us, coming week after week and discussing some things several times over so that we really understood the problem and what the best solution would be for them. But the most interesting and the most valuable piece of elicitation that we had was when we got to visit the organic farm and we got to see exactly how our software was going to tie in with the daily goings-ons around the farm. Being able to apply and see real-world scenarios happening in front of our eyes also opened our eyes to the unpredictable nature of agriculture. Especially with research and development, they're going to be testing new ideas, creating new paths forward, and it's not always going to be perfectly structured and standardized. So customization and flexibility became the quality attribute that we didn't quite expect in this product.
So here are some of the key players in our tech stack. As far as client side, we chose to implement ANTLR. This is something that our team and also the sponsor team has had experience implementing in the past, so that was an easy decision. We started this project thinking we were going to use C#.NET, but after meeting with Wegmans' enterprise architecture team, they convinced us to move towards .NET Core, which is an open source alternative to .NET. This offers a little bit more compatibility with different operating systems, and we aren't sure on how many machines this application will run, so we'd like to keep our possibilities open. And as far as backend, this was more dictated to us, as Wegmans will be inheriting this code base after we're done. We thought it would be easiest transition if we just use what they're using right now.
So to really immerse you guys in the kind of data that we're working with, I'm going to walk you through an example of how one crop plan might exist in our system. So you think about putting a crop in the ground and all of the information that you're going to have to hold on to in order to look back and understand everything that happened to it. So first of all, where was it in the ground? What plot was it in? How big was that plot? Because you want to be able to standardize the yields that you get from that harvest down to yield by foot, yard, acre, so that you can compare it to past and future harvests as well. Crop information. What is in the ground? Is it a specific variety? And what kind of products are you going to be able to get out of that crop? And we'll talk about products in just a second. But the real meat and potatoes of this is the whole life cycle. Every small and major event that happens from the moment it goes into the ground to the moment that it's pulled out of the ground. Any sprays, treatments, how often it's watered, all of these things can affect the yield and the success of the given crop. Back to products for a minute. We define a product as a way that something is packaged and delivered to you, the consumer, in the grocery store. So when you're buying broccoli at Wegmans, you can get it in the little bite-sized florets, or you can get it in an entire head. So each of those are two distinct products that can come from the same crop. And they also might be distributed to the same customer, which is why they exist under a single object of distribution.
In terms of deployment, Wegmans was kind enough to give us a Microsoft Azure server. So when we pushed to our master branch, the Azure server will relay the changes as a production server. We're also planning to use the VM given to us by the SE department as a staging server for continuous integration. When we develop, we're using feature branching to manage our code base in Microsoft Teams services. So for example, Luke will be working on adding a crop, and I'll be working on adding a distribution as a feature. And we are also fortunate enough to have a bi-weekly code reviews with an engineer from Wegmans and taking feedback from him, which was very valuable. Also, we integrated Slack with Microsoft Teams services so that whenever a merge occurs, the result of the build is relayed to us. This helps us keep in check basic bugs and errors, and we know the general cause of the error.
So here's a quick overview of a high-level architecture diagram. It's a pretty simple MVC, slightly modified because we have both AngularJS and C# controllers. To give a quick run-through, the AngularJS controllers provide information to and scrape information from the views. The C# controllers are in charge of the basic CRUD operations with the database, and the C# models are populated with this data using Dapper.
For testing, we couldn't test the validity of the data, since hundreds of database calls every time we test it wouldn't be efficient. So instead, we tested the business logic of the controller, such as the response code it returns when we give it a certain input. Instead of calling the repository with the database calls, we use a mock repository to return a mock response. So since we decided this semester we're standing up the database and all the data the application needs, we're spending next semester testing usability, and to test it, we're asking our domain expert Nate for feedback, and we're going to use it to incorporate changes and refine it. We're also looking into using Selenium for basic web application testing.
Our risk management process begins with the creation of new risks weekly during our core-ups. This is done to make sure that our new risks are representative of the current state of the project. These new risks are then transferred to our dedicated risk management spreadsheet document, a portion of which can be seen on the next slide. As you can see, each new risk that is put into this document is analyzed for its probability of occurrence and its impact on the project in terms of weeks. These two metrics are multiplied to get our risk exposure, which determines the priority of the risk. The priority of the risk is denoted by color on the spreadsheet, red being high priority, orange being normal priority, yellow being low priority, and gray being inactive. These risks are mitigated using 1 to 2 mitigation approaches, each high priority risk is assigned a person, so that to make sure that those mitigation approaches are being implemented and make sure that those risks will be mitigated. Also, once to twice sprints, we will reanalyze every risk in the document to make sure that their priorities reflect the current state in the project. So we know which priorities we really have to be worried about, which ones we don't have to worry about anymore, which ones have turned inactive. Our major risks, our high priority risks in the past, have been risks of all types, mainly caused by the problems we've had integrating technologies we were not familiar with into the project. Our current risks are schedule type risks, caused by the backup of user stories from past sprints into this sprint due to a lack of testing on those user stories due to an absence of a testing setup that was caused by the difficulties in integrating new technologies we're not familiar with into the project.
So we're going to talk a little bit about our progress through each of the sprints that we've worked in development. The first one, we really dealt with a chicken or the egg problem where we weren't quite sure where to start. We had all of this data that was very deeply intermingled with each other, and it was hard to decide where to dive in. This also kind of led us into falling into a trap where Microsoft Team Services hadn't been quite set up for us until several weeks into the sprint, and we decided that we felt it was best to just wait for that to be set up so that we could have a clean start to our development. The trade-off on this was that we spent a lot of time looking at our design, evaluating our design, re-evaluating our design, and doing our best to understand it as deeply as we could. So you can see how all of this played out in our burn down. About half of it was spent doing not a lot of actual forward progress in terms of development, but once we got started, we really kicked into gear and worked hard to make sure that we had a viable first demo to show to our sponsors.
So after the end of Sprint 1, you all saw the really steep slope, and we were really trying to prevent that from happening in Sprint 2. We compensated for this with adding a lot more time for development. As you can see here, we spent almost 50% more time in development in Sprint 2 than in Sprint 1. While this seemed to be a good solution, this didn't necessarily mean we were being more productive with our time, because a lot of the time, like Colton mentioned, we were running into some technical issues that most weren't really getting any headway on, and it just added for a lot of stale hours. We also were a lot more ambitious during this sprint. We tackled twice as many user stories, and we really wanted to aim for the stars on this one. As you can see, here's the burn down. In the beginning, it starts a lot more fitting towards the ideal line, but at the end, we ended up getting a lot more rollover stories. This can be attributed to us not explicitly meeting the acceptance criteria, and as you can see here, it almost seems like we did less work, but we ended up closing out a lot more user stories this sprint, despite having more to start with.
Sprint 3 is the sprint we're currently in. I can't tell you all the details of it, but I can tell you most of it. Our plans for this sprint were to complete the test of the user stories that were backed up from previous sprints, to start searching capabilities for the project, to work on distribution functions, distribution of products from the farm to make the project for, and starting background calculations that would otherwise be, or in the past have been done inefficiently compared to how they could be done on this project. The main things we've been working on so far in this sprint are setting up AngularJS unit testing getting those test done on those user stories and working on those distribution functions. And these activities can be shown on the burn down right here. We have done all of the tests for the backup user story so far, and that is reflected on the downward slope of the sprint. As you can see it, and the slope at the very end is representative of our inability to add data to the burn down past that point because we have not ended the sprint yet.
So we as a team feel that we had set too high of a goal for ourselves this semester, especially not taking into account of all the setbacks. But we feel pretty comfortable with our progress given that we had nothing to start with. So here are some screenshots of what our software looks like now. As a reminder, our focus for the semester was the data and traceability of the crops and cropland. So our application looks fairly simple as of now. Our data is entered through simple, unstyled forms, and here's an example of entering data for a plot. You can have the plot name, the length, and the width, and we can view each item in this page and its values here and click on them for any edits. So the plot name, length, and width are listed here.
As for what we took away from this first semester, we felt that we've done well in planning. We dedicated our whole first sprint 0 to planning. We spent a lot of time in our constant weekday meetings on documentation dedicated to planning. So we have really extensive planning we're proud of. We also have established really reliable contact with our sponsors. Whenever we need to contact our sponsors, we can do so quickly and get feedback, reliable, good feedback in a very time-efficient manner. And something we'd like that went poorly is our schedule in general. The schedule didn't go the way we planned because of the issues with the testing setup. We would be trying to integrate technologies we're not familiar with. And so in the future, we'd like to try to integrate technologies that we are familiar with, like Selenium, for things like usability testing. We'd also like to work towards our stretch goals, our nice-to-have features, and we'd like to possibly change our sprint schedule in the future, as currently the due date for our demonstration of the sprint schedule and the actual end of the sprint conflict with each other and cause issues. So our current winter break plan is to treat the break as a sprint in itself. We feel dedicated to the project enough to make sure that there are times where we remotely meet consistently throughout the break so that we can maintain our Scrum methodology throughout the time, but treat it as a legitimate sprint. And we also like to focus on testing and front-end work during the time where we previously focused on back-end work. Our plans for the spring semester are to make sure we have all of the essential features of the project finished. Things like authentication between different users will be complete and polished up. And once we know that they're fully polished, we'll work on our nice-to-have features for stretch goals so we can extend the usefulness of our project even further.
Are there any questions?
You mentioned using both an Angular controller and the C# controller. Where is your actual management being done? Is the Angular controller on the client or the C# controller on the server?
Angular controller on the client is where most of our navigation is happening.
All right. So you mentioned you had 5 weekly code reviews with actual licenses. Did you run into issues where you had code that you were being used before it was actually reviewed? Where there was issues like you felt off code that was bad before it was actually reviewed with the license?
I'm not sure I follow the question.
I guess I was wondering if there was a mistake in the code, and then for the first week you build off of that code, and then after that you had to review it. Instead of probably not yet.
No, it has not happened, unfortunately.
Somebody makes a simple mistake, it isn't caught because the code review did the length of time is so long that things can slip through the cracks. Just some clarification, you mentioned that in sprint 2 you added more time for development. Do you mean you allocated more of your sprint time for development, or the sprint was longer than the first break?
It was the same length, but we just ended up spending a lot more time on development.
I noticed on your sprints 2 and 3, your burn down isn't really what you're hoping for. You didn't seem to make any adjustment in how many stories you took on between 2 and 3. It doesn't look like you're going to make that this time either. What is your plan to try and get to your burn down rate that you want?
winter break is going to be a big part of that, especially with catching up in testing. A similar thing is happening in this sprint that happened in Sprint 2, where things aren't done because they aren't explicitly meeting the acceptance criteria. So being able to focus and clean those up much in the way we're doing now will be a good way to start with a clean slate in spring semester, but also making sure that we evaluate our velocity and what we have been able to accomplish and keeping ourselves in check for spring semester and really holding ourselves to what we've been capable of and not what we think we can do.
And looking at those burn downs are pretty daunting even for us, and I'm developing it, but a lot of that work is, like we said, just closing out, so it's not proportional to, I feel, the amount of work we actually have left, but it's proportional to the amount of work we need to deliver, so.
Anything else?
Let's thank the team.
Hi everybody, we are Team EZA and our project is called Size It, but our sponsor hates that name, so it's probably going to change. I'm going to go over our project synopsis with you. So our sponsor is Lee Fishman of Galarath Incorporated. Galarath makes what's called SEER software for estimating software size, helps teams plan how much effort and duration a project will take. And through their research, they've concluded that project size is positively correlated with effort, as a lot of us might assume. Here's a graph from our project proposal document with productivity on the y-axis and the amount of functions in a given project on the x-axis. Notice that there is indeed a positive slope. So to conclude from this, we want to, in order to measure effort, we want to be able to measure project size. So how do we measure project size? Well, we could use lines of code, which is very easy and inexpensive, but it's not very meaningful and it doesn't really help you with projects that haven't been developed yet. So there's the method of functional sizing, which is using what's called function points to scope out what parts of the code will take you long to complete, the more meaningful areas. A lot more meaningful than lines of code, you can use it to size non-existing projects based on user requirements, is what that's usually used for. So how does it work? To steal a quote from our sponsor, function exists at a point where the job is finished, so leaves the system in a state of equilibrium. Function points are the points in the code that take input and send output to and from the user. So at the highest possible level, we have a system in its equilibrium state. It gets some input, does something with that input, whether that be internal calculations or simply returning it back to the user through output, and then the system is back at equilibrium, waiting for its next input. And we are concerned with the points at which it takes that input and sends that output back, and that is a function point. Here's a picture from a presentation that our sponsor gave showing what that looks like in a finished product. Of course, this is a lot different from how you would analyze a product that hasn't been developed yet. Like I said before, functional sizing is usually reliant on user requirements. So how do we estimate effort given functional size? Well, one way we can do that is get the size of similar projects with similar requirements and compare by analogy. The problem is that a lot of companies, more likely than not, are not going to have enough past projects sized for this to be useful. So where we come in is that we want to develop a way for organizations to mine the software that they do have and get function points so that they can actually use those sizes. Why automate? Well, it saves time and money, first of all. Functional requirements, or functional sizing is usually a very thorough, extensive process. A lot of times it's done by experts who have done it for a while, and that costs a lot of money. And also existing functional sizing methods, like I said, are reliant on user requirements, which some companies might not have the user requirements for past projects. They might only have the source code. And then one additional advantage of using the source code is that source code is going to be more accurate than assumptions based on user requirements, because it's what's actually been built as opposed to what you think it needs to be built.
So I'm going to talk about our process a little bit with this project. Firstly, I want to talk about some factors that went into influencing our project and how this project is kind of different than most typical software development projects. So the first thing is we only have one main requirement, and that is to automatically produce a functional size from an existing project. And the other minor requirement is that the project must run on a Windows machine. So conversely, we don't have a long list of requirements that we could immediately design code for up front. On top of this, we know that the project will be heavily research-oriented. It's kind of unexplored territory. Not a lot of people, if any people, have really done this, at least in a thorough way. So we're going to need to do a lot of research up front. We have this goal in mind of automatically producing a functional size, but we really don't know how to get there. And with it being an unfamiliar domain for our team, that is because none of us have extensive experience with doing project estimation. Usually that's people who have a lot of experience in the field. We were going to have to do a lot of research anyways. So with those factors in mind, we definitely need a process that would be highly iterative. We know that we will have to go through some iterations of research, and then the project requirements will come as a result of that. And it's also very likely that the project direction could change as we gain more knowledge through our research. So with that in mind, we agreed with our sponsor that we should take an agile approach on this project. So we tried to develop a Scrum-like methodology, but tailor it to our research needs. So with that said, the tickets and user stories have become questions, because at the start of the project, we really just had a lot of questions that we needed answers for. So each week we would come up with questions that we thought were good questions to research, and we prioritized those and then gave them out to our team to go out and find an answer for. So some of those questions might have been something like, is this tool ANTLR going to work well for multiple programming languages? Or which function point analysis method is best for our automatic process of going through source code? So with those questions, our team members would go out and read research papers, investigate tools if there are any existing, and really just trying to see if anyone has tried to do this before and if we could get some more insight into the problem at hand. Then eventually, we hope to transition away from this process of questions and transition more into a more development-focused process, because we can't, or we know eventually we'll reach the end of our research phase and need to start focusing exclusively on coding to develop a product. So with those questions, one of the main metrics that we're tracking is related to the questions answered. So we track all of our questions and their answers in a document and spreadsheet, so that we can see how many questions we are able to answer each week, determine if they were useful or if they were possibly dead-end questions. And this is our effort to try and track progress throughout the development of the project. With research, it's usually kind of hard to determine the end of the research and such, so this is at least our attempt at determining progress, and we thought that this would help let us know if we're kind of reaching like a burnout. Towards the end of the semester, we've kind of been realizing that we don't have as many questions anymore, so that's kind of a sign that we should start focusing more on our design and code. And then the other big metric that we are tracking is test coverage. Obviously, testing is important with any project, but we thought it would be very important with this project because we need to be able to have accurate, reproducible results. And in general, it also just keeps us honest, so when we're checking in new code, it doesn't break the old code, all the code should pass all the existing tests, etc. I also want to talk about some risks associated with this project, and one that I've kind of touched on already is that the project might have been too research-based. The research could kind of get out of hand. We don't know, you might not know when the research should end and when you should really start coding. So we've tried to mitigate that as much as possible with the questions and answers and being pretty strict in our process of documenting all of our research. And the other added benefit of that is that all of our research is sitting in one document, so to share the knowledge with our team is very easy. You can just open up the document and see the answers to our questions. Another big risk is, how do we even know if we're measuring the function points correctly? We might come up with a number that represents the functional size of a project, but we don't know if that's correct or accurate. So how we will know if we are right is our project sponsor will be sizing some projects for us, and we will also run those projects through our tool so that we can compare the results and see how accurate and correct we are. And this is also especially important because we are automating the process of determining functional size. Source code. My laptop is fine. Okay. Anyways, like I was saying, we're automating the process of determining functional size from source code. So a lot of the traditional function point methods don't apply to source code. They're more focused on requirements, as we said before. So we'll likely be coming up with our own hybrid sort of method. And with that, we need something to test against. So our project sponsor will be sizing some projects and we'll compare against that. Also, at the start of the project, we had a lot of discussion about what language or languages we should be targeting with this project. Our sponsor had high hopes that we would be able to target any language with this project and be able to plug any project in and determine its functional size. But after doing some initial research, we determined that that scope would be too large for this project, and we decided to target one language initially, at least for the time being. And so to kind of mitigate that risk of putting all of our eggs in one basket, we tried to keep our design and code from the start as open as possible to the addition of new languages in the future. And that actually ended up helping us a lot because we decided to target C initially to determine the functional size from, but we found some problems with C and had to transition to a new language. We decided to move to Java, and the transition was pretty painless because we kept our design and code as open as possible. Then in addition, it turns out that there's not a lot of publicly posted function point sizes of past projects, so our project sponsor and ourselves are likely going to have to hand count a lot of projects in order to compare our results to.
So I'm going to talk a little bit about our approach in research and solving this problem. So first off, just some of the tools that we used. We use Google Drive, Slack, and GitHub mainly for communication and process tracking. And we use Java for our language of choice for implementation, Git for version control, IntelliJ for our IDE, along with Maven and JUnit. Nothing special there, but ANTLR was our most influential tool, and that's what I want to focus on next. So ANTLR stands for Another Tool for Language Recognition, and essentially you can give it a grammar file that specializes the syntax of a certain language or set of text that you want to parse, and it'll give you an API, specifically in Java, that'll allow you to parse and walk those languages to pull information from. So some of the benefits of ANTLR was that it allowed us to skip the long, arduous task of creating a parser for a language and testing that parser. None of us are really that keen on that type of area, so that would have caused us to spend a lot of time there when we could have spent it researching and developing the actual function point analyzer. Also, a lot of the grammar files were already created for us. They sit in a GitHub repo somewhere that we were able to pull down, so tested and verified C grammars and later Java grammars. And it allowed us to change our targeted language about 5 to 7 weeks in, from C to Java. And the reason that we did that was C had two major problems. One of them, there weren't a lot of open source C projects for us to pull from that would have been easy and simple enough to test against, at least in the beginning phases. And additionally, C has the ability of a preprocessor, which grammar rules in ANTLR just cannot handle, because the C preprocessor can do just about anything that the developer wants it to do, and that just wasn't going to be possible. So really quickly, this is our system level architecture that we have at the end of our project, where we currently are right now. And I want to sort of walk you guys through our research approach, since we don't really have a demo or a product that we can show. I want to kind of bring you guys through that. So initially, our sponsor had the idea that we would be able to get an abstract syntax tree using ANTLR and compare it across projects and across languages, that the syntax tree would hold some sort of data, some sort of information that we could just pull function points from. So we started with that approach while we were also researching Cosmic and function points and other things like that. So we started to notice that that was going to be a problem, though. So for example, here's a sample C file. It just got two functions in it, both of them under 15 lines of code. And here's a snippet of the abstract syntax tree. This is about 1/4 the size of the syntax tree created by that file. So knowing that we were going to deal with massive amounts of file of massive sizes, this approach was going to be pretty difficult. So we wanted to speak to a subject matter expert about this. So Professor Fluitt in the CS department, he works with grammar parsing and abstract syntax trees, and he basically verified that comparing grammars across languages or even within the same language, comparing syntax trees within the same language just wasn't going to be possible, and wasn't an approach that would really give us any results. So we decided to move on to create this intermediate model to help us basically make relationships between the abstract syntax tree, the major abstract syntax tree tokens and portions that we wanted to focus on. And we weren't quite sure when we started the intermediate model what we would use it for, but we knew we would need something in a different state than that complex abstract syntax tree. So as we continued to research different options, we were also slowly building this and getting more familiar with ANTLR. And this was about the time when we switched from C to Java. So this is our intermediate model. It's kind of complicated and there's not much point going into it, but this is what it looks like conceptually. So we have a list of project files which contain a list of, within a project, which contain a list of classes, that contain a list of methods, and contain a list of block statements like ifs and expressions and things like that. So with this type of an architecture, we're able to very easily find out, different relationships between the individual items and actually analyze those for the information that we need. So where we are now is we're on the functional size analyzing portion, actually getting function points from it. And the way we're doing that is we're taking user input and keyword files, and I'll show a quick keyword file in a minute. And those keyword files allow us to do symbolic lookups in our intermediate model to find reads and writes and inputs and outputs to our system. So here's an example keyword file for the standard library. It's got every public class and method. And you can see in that little red circle we're marking certain ones that are reads or writes, so that later on we can read this in and make those symbolic lookups. We spoke to Professor Mehdi in the SE department, graduate labs, that to help verify our approach since he has experience in this type of area. And he basically said there were two ways of solving this: a data mining machine learning approach or our approach. So right now we're working on creating and vetting out that Java standard library keyword file, expanding and simplifying our intermediate domain, and recognizing read, writes, and data structures within the intermediate model.
Okay, so moving forward, since we're moving out of a research phase and into more development, we'd like to modify our process a little bit. We're going to be sticking with Agile, but shifting our focus more on development. And we'll also be using tasks instead of user stories. Since our system isn't really user-based, user stories don't really apply. And on top of that, our sponsor doesn't like user stories, so we're going to be going with tasks. We'd also like to switch metrics. Questions answered was perfect for when we were doing research, but it doesn't really apply anymore. We're not entirely sure which metric we'd like to use. A possible one would be measuring our system accuracy, which would be comparing our system's output to the hand-done function point analysis by our sponsor, and that would tell us essentially how correct we are, but this is still in discussion, so we'll be deciding that soon. We plan on delivering two things in the spring. The first is runnable jar, which is essentially the system takes in source code, outputs a functional size. And the second is a framework keyword file creation tool, which will aid in the creation of the keyword file that Eric had mentioned previously, that was used to determine reads and writes. A few lessons we had learned, the main one being language parsing with ANTLR. ANTLR is very powerful, and it makes text parsing extremely simple, and I could see any one of us potentially using it in future projects. This project also taught us that not every project will be a traditional development project, and that we were very heavily focused on research in the beginning and are slightly getting into development now, as opposed to the requirements gathering, design, and then implementation that you normally see. We also found that it was important to keep on track. At times, we were unsure if we were going to be able to accomplish our goal, but we kept pushing forward, and now we're at a time where we can confidently say that we will deliver. Lastly, we learned that metrics need to be selected based on a project, and it really needs to be focused on the project context. A quick summary of our research. Abstract syntax trees can be extremely messy and aren't really something you want to deal with directly without any form of augmentation. Comparing syntax trees across languages is not practical or possible. And analyzing the inputs and outputs to the system through the symbolic matching that we do seems to be the best bet. And we really need user input or outside knowledge for the system to be accurate. Automating this completely isn't entirely feasible. And that is all we have. So any questions?
What would you say has been the biggest pain point in using your chosen methodology with a largely research-based
project? I think like we said, it's kind of hard to estimate research tasks. So we would go out, we would come up with these questions that we wanted answers to, and we would come back with an answer. But it's kind of hard to measure progress and know if we're actually reaching progress towards our goal. And that was kind of something that we talked about every week with our sponsor, and kind of just verifying with him that we are making good progress towards our goal, because we have this goal in mind of just automating functional sizing from source code. But when you're doing research, you don't really know, like, oh, I've completed this feature and we've hit this point. It's kind of like we have this knowledge now, and our vision of the solution is less blurry now, and we're more focused. So that's kind of been the biggest pain point along, is knowing, being able to quantify our progress. That's been really hard.
Why did you choose to go with the more standard approach of kind of creating? Basically, why did you choose to go with like the data mining / machine learning as opposed to the approach that you're taking?
Sure. So the data mining approach would have involved us finding a bunch of, basically a bunch of code that had a ton of inputs in it and feeding that in, and a bunch of code with outputs in it and feeding that in, and trying to do as many of those as possible to get accuracy. And with that knowledge, and also the fact that data mining wouldn't be as accurate as this approach, our sponsor was not on board, and he didn't want to go that way. Additionally, when the time that we talked to Professor Mehdi and found out about the data mining approach, we were already 10 weeks in. Wow, we had learned ANTLR, we already spent that time, and if we had to make the switch then, we would be learning, none of us have experience with data mining, so we would be learning data mining algorithms, tools, and everything to do with data mining for a good while before we could even start, which wasn't practical.
You seem to have limited yourself to a syntactic model of the languages you're analyzing, when it seems like the questions you're asking about your program could be more easily answered by a semantic model. Is there a reason you haven't considered using a semantic model of those languages instead?
What do you mean by semantic?
So a model of the language that contains type information that's been inferred or annotated by the compiler. That way you can directly look up, say, symbols you know the name of, like IO read exception.
So we do actually. I think that's our approach. Okay. So let me just go back here really quickly. So our intermediate model. So right here we keep these simple tables, and this allows us to keep track of the types, for example, and then yeah.
So you're building a semantic model yourself.
Correct.
Okay. Do you worry that your semantic model may at some point be somewhat lacking compared to the one built into, say, the compiler to the language you're using?
I don't think we have access to the one built into the compiler that we're using, or at least we're not sure of anything to do with Java and getting the semantic model out of Java.
ANTLR was also something that was kind of given to us by our sponsor, so that was like, initially we did a lot of research with ANTLR, and after walking the abstract syntax trees, it's been a lot of research to even get to this point where we're confident in this approach. So at the beginning it was like, oh, we have this abstract syntax tree, like what do we do with it? And then the next step was, okay, we need this intermediate model to make it easier, and then we realized that the best way to get function points would be to do symbolic matching. So that's kind of how we got to that point. And now we're at the point of like, okay, these methods are inputs or outputs, and those will contribute to function points. So it's kind of been a process of research.
Yep.
What was the duration of your sprints, and what was your output at the end of each of them, or your general expected output?
So we actually just did weekly sprints. We thought that was like fine of a time to go out and read some research papers and test out some things. We most of the time had about a question per person, so we were answering about 4 questions per week. It's kind of hard to quantify that, again, because it's just research and there's not a quantifiable output, but I don't know, I think the best I can say is we each had about 4 questions each per week and tried to document it as well as we could.
Okay, that's slide 15.
Hi, we're Team Reactive Healthcare, and we also have a lot to present tonight, so sit tight. My name is Jeffrey Haynes. I will be introducing our domain to you. First of all, we are a senior project team composed of 4 student developers, Connor, Sam, Yi, and myself. We also have a senior project coach, Professor Larry Kaiser. Our project sponsors are Ken Staffen and Jim Brzezorski, who are with us tonight. And at this moment, I'd like to quickly just thank our coach and our sponsors. Thank you for your full support in our learning experience this year. Your involvement really allowed us to direct our own experience, and because of that, I think we're going to be more prepared for our careers ahead. We greatly appreciate the time you've spent with us. Okay. So our sponsor is Orthoclinical Diagnostics. Orthoclinical is among one of the leaders of chemistry analyzers in laboratory sciences. They're based, and their development happens in Rochester, New York, and there they have a great impact on global healthcare outcomes. Medical laboratories have many goals, and we think these are among some of the most important ones. Orthoclinical tries to accomplish meeting these goals by improving the speeds of their systems, the accuracy of their tests, and the interoperability of their systems in healthcare environments. This is a chemistry analyzer. This analyzer takes patient fluid samples and performs healthcare diagnostics. The computer interface you see in here in the top right is where our project work resides. So this is the user interface for our chemistry analyzers. Laboratory technicians will interact with this interface and supply tests to perform, reagents to resupply the machine for future testing, and configure the device. This is our domain model. This domain model depicts the interaction I kind of described. In the top right, you see the lab tech is interfacing with the analyzer, and is also interfacing with the chemical reagents that are used for each test. On the left-hand side of the screen, we have the laboratory information system, which is connecting hospitals and physicians to the laboratory itself. When a physician requests a patient order, information is sent through the laboratory information system to the analyzer through one of the selected communication protocols. After the analyzer has computed the results, it will send the information back to the laboratory information system for physicians to access. Here is the table of the communication modes that are given to us. On the left-hand side are the legacy modes that Orthoclinical's analyzers currently implement, and on the right-hand side are the 3 communication modes we will attempt to implement by the end of the semester. On the left-hand side, you can see the ASTM communication mode. This is a competitive standard, but it's currently losing its edge in the market because of newer and more exciting standards such as IHE and HL7 Fire. Originally, it was designed for serial communications, and this has a limitation in that the messages are of a strict specific length. So in order to send a certain amount of information about a patient, you might have to send multiple messages with redundant headers, and that can incur performance costs. Unlike HL7, which is terminated by a carriage return, you can send much larger messages. HL7 is also a competing standard. Its support is actually on the rise due to the new IHE and FIRE standards that build on top of that. Currently, our existing HL7 implementation is half duplex, which is unidirectional communication, and this has the limitation of not being able to send as much data as you would like. So in our future implementation, we'd like to upgrade the communication protocol for our HL7 messaging standard library such that it will communicate in full duplex. On top of HL7, IHE law is a new networking mode standard, which enables orthoclinical to sell devices to diverse ecosystems in laboratories and connect their devices with machines that may not be their product. So, as an extra goal, we as a nice to have, we would like to extend their existing GUI interface such that they can configure the new modes we're implementing. This new GUI interface will extend the options to select and configure your new communication mode. This is our domain. Thank you.
Okay, so when we started this project, we were given 3 goals to kind of highlight our project. The first one, as Jeffrey was saying, was the full duplex communication. The second being the IHE law LDA profile support, and the third being a fire implementation. If Jeffrey didn't explain, the stretch goal is that we're going to implement a fire demonstration by the end of it. We may not get to that. It's something that we want to get to if we have enough time. If there's too much time that we need to implement for the first 2, we're going to kind of put fire on the side and work on the first 2 to really deliver those as priorities. So right now we're in kind of the half duplex mode where we're really working towards implementing a full duplex solution. So currently the half duplex limits the current system so that it's only unidirectional, as Jeffrey was saying. So right now the LAS really can only send test results, and as soon as it goes into that sending test results phase, it cannot accept analyzer results back. So right now what we want to try to do is provide a simultaneous transactions between the 2 systems so that if the laboratory information system is sending a test order, it can also receive an analyzer result back. So right now, full duplex is well on its way. We don't really have a lot of experience with TCP over IP, which is what this is using to handle the 2 kind of transactions between the 2 systems. So I'm the only one with it, so that's kind of why we have a lack of it. What we've mitigated that is that our sponsors have been great at responding to us if we have any questions. I've kind of taken like the lead in the TCP over IP kind of communication, but them and myself have also done a great job of communicating it to our team so we can all be on the same page. In addition, the QNX and Ortho API, they have their own APIs using for their program, so there's different TCP IP functions that I have to get used to because I'm not used to implementing on QNX, which is its own operating system. And Ortho also has its own legacy kind of functions that are different, and then I have to investigate Ortho and ask them, what does this do? Like, how does this actually interact with the entire system? So interacting with those is kind of like 2 stepping stones we try to kind of traverse over. There's no really mitigation for that except for just kind of plowing through. And largely, since we're inheriting a large code base, a kind of a really old legacy system that's still working properly, we've also had to just get used to it in general. My experience at Excel's Blue Cross Blue Shield, it's kind of like helped me in that. I had to inherit that large code base, and so our team co-op experience in general has helped us really accept the large code base and really deal with it head on. So we've already kind of nailed down that full duplex needed as a listening socket. So really, the LAS is going to be taking on, in our kind of added implementation, the LAS is going to be taking on the client side of it, and the analyzer is going to be adding the functionality of the server as well. So it's going to kind of go through the normal interactions between the 2, except for during the read and write data phase that normally occurs in this kind of interaction. That's going to be where we're implementing the simultaneous transaction phase. So in addition to adding a listening socket, we're also going to have to modify the existing state machine diagram. This is kind of like a snippet of their overall state machine diagram. It's really complex, so this is kind of just a nice implementation that you can see like the overall idea of what it is. So basically it starts off in a connected phase where the LAS is connected to the analyzer, and then it can either go into the sending phase, where as soon as it goes into the sending phase, it can no longer go to the receiving phase, and you really get that same interaction. So what we've decided to do is duplicate this, not so much that they have the same functionality. We're going to implement one where it's an outbound phase, where it can really only do the sending and sending portion of it, and so it still has the functionality of the receiving phase, but it's only going to be focusing on the sending portion of test orders. And then we're also going to have an inbound where it's connected and it goes to the receiving phase, and that only really focuses on the receiving of the results back from the analyzer.
By supporting IHE law, analyzers from different vendors can conform to a profile which allow interoperability to without need the customer device drivers. And IHE law profiles are based on HR7 2.5.1, and we will modify the existing implementation to support IHE law file on the analyzer to increasing its effective interoperability. And we will implement defined network mode described in standard documentation. In the broadcast mode, the analyzer manager is responsible for initial transmission of walk all the steps to the analyzer, and this mode would also appreciate for transmission for orders from order filler to the analyzer manager, and after adding ANTLR file support, ANTLR support, the system still supports the lower version of HR7, and also this implementation works with the full duplex mode. At a stretch goal, we will demonstrate an implementation of a new use of HR7. It known as FIRE. FIRE is a next generation standard framework created by HR7. It uses RESTful web API for exchange information, and FIRE is published as a Drift standard for trial use. It combines the best feature of HR7's version 2 and version 3, and it also supports the exchange of HR7 messages.
So for our scope, as we mentioned, we will be creating a full duplex mode for HL7 so that tests and results can be sent bidirectionally at the same time. And we will be implementing IHE law, and if time permits, then FIRE. In regards to IHE law, we will need to have full compliance with the profile, and we will validate that using Gazelle tools, which we will talk more about in a bit. As for what's not in scope, the ASTM protocol is not going to be made full duplex. It's no longer used as much as HL7. Ortho has customers around the world, so the system does require localization. However, that's out of scope for us. And we are also developing using virtual machines on our personal computers, so we won't have to work on using the system in a production environment. For our requirements, we're using Bugzilla and Trello. In Bugzilla, we have entries that are either requirements, bugs, or action items. The reason we're doing Bugzilla with Trello is that each entry in Bugzilla has all of the details listed out, and it's indexed and searchable. But then each entry is mapped to a card in Trello, which is then organized as a Kanban board, which is our methodology. The reason we chose Kanban is that, first of all, it works well with Bugzilla and Trello, but also it puts a lot of emphasis on keeping work moving from left to right. If you're not familiar with Kanban, each section, whether it be analysis, development, validation, has a work in progress limit. So if analysis is all full and we want to add another card, we have to make sure that one of the existing tasks is moved on to development first. And also, this is great to have to interact with our sponsors if they want to reorganize any tasks so that they match what they believe should be highest priority. They can do so without disrupting our workflow. So this is a picture of our Trello Kanban board. As you can see, some of the cards look old and withered. There's a plugin for Trello, which is kind of corny, but it gives us an actual visual idea of which cards have kind of been forgotten about and have been staying in each column for too long and require more attention. So just to zoom in real quick, we have our backlog, which is all of our action items. Requirements, which is once they're filed in Bugzilla, they go to that column. Once they begin work, they go into analysis, where we determine what work needs to be done to complete the requirement. Development is when they're actually being worked on. Validation, once they're done, we need to make sure that all of the requirements have been fulfilled, and then finally they are moved to the done column. The analyzer is in a QNX environment, so we're using Oracle VirtualBox, as I mentioned, to run it as a VM, so that way we won't have to work with actual analyzers on Ortho's campus in order to test our changes, which is great. It's nice and convenient, but it does have a slightly different network setup than the actual analyzers, which is something we need to work around. For development, we're using QNX Momentix, which is an IDE. And since the code base we inherited is so large, it really helps to be able to navigate through the code and see how different aspects interact with each other. Plus, there's a debugger, which allows us to work through the code line by line to figure out any bugs. And last, the Lab Interface Test Tool, or LIT, is software provided by Ortho, which allows us to simulate the LIS, again, so that we don't need to go to their campuses to test our system. And this is just a diagram of our development environment. As you can see, in the Windows environment, we have our analyzer software running in a QNX virtual box, and Momentix IDE is modifying the source code and acting as a debugger, and the LIT tool is running as an instance to send test orders and return test results so that we can ensure that our system works as expected. Like all the other teams, we are using 4-ups every week to determine if our risks are prioritized correctly, and also this helps if the sponsors provide their experience and expertise to let us know if some certain risks require more attention than others.
Gazelle is a suite of tools developed by IHE. Gazelle tool allows testing the interoperability of the medical systems, and it also offers a test manager solution for testing the interoperability of e-health software components. And the current system supports HR 7 2.5 and will be upgraded to support HR 7 2.5.1. And we will use the Gazelle HR 7 validator we will use the HR 7 validator to check if the information HR 7 information is correct. And for the verification, we use Kanban to manage our project. It helps us to analyze our requirement and to visualize the workflow. And we will use unit test to test the functions and classes to assure the software fully satisfies all the expected requirements. Code review are conducted among each of us. When one member plans to commit code, while other members will go through the changes to check if there are the bugs. This is our process metrics. We chose the estimation accuracy for our process metrics. This metric demonstrates our ability to judge the amount of the effort that the task takes each week. And the equation is estimate hour minus worked hour divided by estimate hour. And the line, the closer the number is to 0, the better we estimate the tasks. And this is our project metric. We choose the bug analysis for our project metrics. On the left chart, the blue line is the number of the bugs raised, and the red line is the number of the bugs closed. And on the right chart, the line is the ratio between the lines on the left chart. The higher the line is, the more effective we fix the bugs. And this is an example for this matrix. The data on this chart is not exactly the data from our project, since we are still in the early stage of implementation, so we don't have enough data for this metric. Currently, we are working on the system is so complicated and it has a lot of code. So we spend time on learning and analyzing the system. Therefore, we are behind our schedule. But we have more confidence in the future development since we know the system better and better. And in this winter, we will research IHE law and start to modify the implementation in the next semester. And for team dynamics, we focus on process each phase. Everyone in our team has some advantage in some areas. So the jobs are assigned to team members who was interested in the job or who has some experience with it. Like Connor is working on the full duplex since he has the basic guy in our team has some experience about the network, and Sam working on the data machine.
Okay, so we're running a little short on time. I kind of just highlight a little bit about what went well. One of the greatest things has been open and consistent communication with my sponsors. I know a lot of you have said that as well, but that's really been a highlight for us. Being honest is another research problem or another research project. We really had to get a lot of information from my sponsors and elicit from them. So that was really important. The last I would like to kind of highlight is our establishment of project processes and tools. So we chose them really early on, Bugzilla, Trello, as well as Kanban. We chose those really early, and we knew we wanted to use those, and those were not a problem at all integrating them within it. We didn't have any learning curve to really get understanding what they were. We got right through them and just implemented them right away. So this is like project progress where like problems faced are currently facing. One of the biggest ones was learning the domain, like I just said. We leveraged experience from our sponsors. Team task visibility was something that was going on recently. We mitigated that by using our in-place process. So we've had all this process in place, but we kind of stepped away from actually using it. So what we really had to do was just step back and really look at our process and how we could actually really utilize it to the best that we could. So we stepped back, looked at it, and really analyzed what we could do, and now we're doing a lot better visualizing what we're each doing within our tasks. And the last is the ability to recognize the source of requirements. So we thought early on that we could elicit a lot of these requirements from our sponsors, and that was a little greedy for us to kind of assume. So what we had to do is we had to recognize that these were problems that our sponsors were also giving to us, so they didn't have all the knowledge themselves. So we had to use external sources as well to understand our problem really to the best that we could.
And finally, this is our schedule. We're hoping for the spring semester. Connor and I will be working on full duplex through the winter break and up until week 7, while Jeffrey and Yi will be working on IHE law. And then once we are done with full duplex, we will help with the implementation so that we can start testing by week 10. And as we mentioned, FIRE is a stretch goal, so that's why it's a dotted line. We may get to that, but it is also possible that we could use that time to help with testing for the existing functionality. Thank you very much.
Any questions?
So you guys are dealing with healthcare data. Was HIPAA compliance a risk that you were thinking about or have been thinking about?
Yeah, we are using all simulated data right now. We don't have access to any actual real data that might be private to someone, but also we did sign an NDA to ensure that none of the internals of our system are talked about outside of our group.
It seems like that question could also be applied to the actual software itself, not just your involvement in the project. So, kind of redirect that question.
So if the question is about validation, and if the question is about like how would you validate, is your system HIPAA compliant? Is your system compliant with the FDA? Our sponsors have kind of struck that requirement from us down a bit, so that we're not having another knowledge spike related to the large complexities of healthcare validation. So they can kind of assist us in what is the right design and what is the proper way to do things, but they kind of remove the scope of validation and code reviews related to healthcare. That helps.
Any other questions?
On your slide about your plans for next semester, it looked like you're waiting until week 10 to start testing. Are you concerned at all that putting it off to the end might cause problems?
So that's kind of like the last polishing phase within it. So right now, we're still in our design phase for really how we're implementing full duplex. That's kind of why that winter break is there. And starting week 1 of spring semester, we really want to dive in and really get into the actual implementing the state machine code that we have to do, implementing the listening stock. Right now, it's kind of like just haphazardly in the code base. We really need to formalize that. So the testing phase is really in there for the very end, verifying everything. Obviously, throughout each week, we're going to be unit testing. Maybe the code that we're doing, we can actually have these guys test to make sure they're running through all the unit test cases that we're doing. So that's really at the very end, just verifying all the last touches, making sure everything's in place, so that if we give it to them, it's in place and actually working correctly. So that's not the end testing. That's not the only testing we're doing. To answer your question.
And then also, as I mentioned, the FIRE is a stretch goal, so if necessary, we can use those last couple of weeks to test the existing features.
Any last questions? Sure.
Have you thought at all about security aspects and the communication of data over the network? encryption, authentication, authorization, that kind of stuff?
Not so much.
Well, we're not really adding any additional functionality as far as the network goes. We are only modifying the existing functionality to work bidirectionally. So we haven't been working on adding any security measures that weren't already there, but all of the transactions are already in the system.
And I think a lot of these systems, although there may exist security that we're unaware of at this point because the scope of an existing analyzer is so large, these systems live in a laboratory environment where they can have a secured network wrapped around these existing systems. So it kind of, reduces our need. They're not accessible from an external source without going through a secured system. So, yeah. It's not IoT analyzers yet.
All right, thank you.